In this lesson, we are going to look at how to teach the concept of circle theorems using GeoGebra. When you launch your GeoGebra, this is how it is going to look like. But we don't need the grid and then the XY plane. So let's eliminate that. Right click on your mouse and you see show axis. So I click on show axis and the axis has been eliminated. I right click again on my mouse and then you see show grid and then click on show grid. You see no grid and the grid has been eliminated. I want to select the circle here, circle with center and radius, and I click on that. Then I'll come to the part of the background where I want to the circle to be drawn. Then I click on that. You see, what radius are you going to work with? I want to use radius 3 and I have radius 3. I don't need this C here. So I want to eliminate that. You right click and you see show level and you click on show level. It has been eliminated. I want to rename the center. So come to rename, right click and come to rename. And then I want the center to be O. Then I come to the text icon here. Let's click on text. I want it to be here. So you see, I'm going to write my property here. You see, angles suspended from the same chord or arc at the circumference of the circle are equal. So that property that we are going to look at. We come to the line segment and then we click on segment. So I want to have my segment here, segment AB. I come to move, I want to move my labels outside. Also, I don't need the label F there, so I click on the line. Then I come to show label. F has been eliminated. I come to segment again and I click on segment. So I have angle ACB. Then I have angle ADB. And then I have angle AEB. All on the same chord AB. So I don't need the labels. So I click on the line, show label. It has been eliminated. I right click again, show level. It has been eliminated. I click here, show level. Right click here, show level. So this is what we have. We are now going to measure our angles. So you come to angle here and then select on angle. So I want to measure angle ACB. I want to measure angle ADB. And I want to measure angle AEB. So you can see that angle ACB is giving us alpha equal to 62.91, beta is equal to 62.91, and gamma is equal to 62.91. So this clearly shows that the angles that suspend from the same chord at the circumference of the circle are equal. Now, I don't want to show the levels here, alpha, beta, gamma. So I want only the value. So I right click on that. You come to settings. So you see show level, name and value. So you click on that. You need only value. Come here, you right click, you settings. So show value. So again, we can come to this settings here. So the decimal, we need the decimal to be 0 decimal. So in this case, it is giving us only the whole numbers. So here, we right click here and we come to settings, then we show only the value. Also take note, as we change the positioning of the chord, the angles keep changing, you see, but they remain the same. So 74, 74, 74, they are still equal. So this clearly shows us that the angles sustained at the circumference of the circle from the same chord are equal. The next property we are going to look at is the angle at the center of the circle is twice the angle at the circumference sustained from the same chord or arc. So we have our circle with the center O. So let's select from the line segment and select segment. Okay, so I don't need the labels here. So I right click on the line. Now show levels. I click there. Okay, then let's come to angles and select angle. So I want to measure angle AOB and then angle ACB. So the property says that the angle at the center of the circle is twice the angle at the circumference sustained from the same chord or arc. So the angle that sustained at the center here is twice the angle that sustained at the circumference here, sustained from the same chord or arc. So this is my chord, my arc AB. So if I want, I can extend this chord here. So this is what we have. Now let's change the names of the, so come to settings. So we have value. And then from here, come to these settings, 0 decimals. So you see that we're having only whole numbers. So I want to eliminate the alpha. So I come right click and come to settings. So this is what we have. But okay. So clearly we can see that choice of 57 is giving us 114. So that is all about the property. Twice the angle that sustained at the circumference of the circle is the angle that sustained at the center when they are all on the same chord or they are the same arc. The angle a diameter sustains at the circumference of the circle is right angle. Thus, angle in a semicircle is right angle. So what we are saying is that the angle that sustains through the diameter at the circumference of the circle is equal to 90 degrees. Right angle means 90 degrees. So first of all, let's select from the line segment and select segment. So from A, we have segment AB. So let's move. Okay, so the line that passes through the center and divides the circle into two equal parts is what we call the diameter. So let's select again from the line segment and select segment. So we now have angle ACB. Okay, so let's measure the angles. So from here we select angle and we measure angle ACB. So we see that we are having the angle to be 90 degrees. So we have angle ACB to be 90 degrees. So that tells us that the angle a diameter sustains at the circumference of the circle is right angle. So this is what we are having. So we can also measure angle angle BAC, and then angle CBA. So you can see that the sum of the angles in the triangle is 180 degrees. So 90 plus 39 plus 51 is given as 180 degrees.